Prepare to be amazed as we uncover one of the greatest milestones in space exploration. NASA has confirmed that Voyager One, our intrepid space traveler, has boldly gone where no human-made object has gone before. It has exited our solar system and entered the vast, uncharted interstellar space. Launched in 1977, Voyager One, alongside its twin Voyager Two, has been journeying through space for over 4 decades, equipped with state-of-the-art technology, including infrared sensors, imaging devices, and advanced radio systems. These pioneering spacecraft have continually sent invaluable data back to Earth, defying expectations with their longevity. As we approach 2030, the year scientists predict their batteries will finally deplete, Voyager One has made a groundbreaking discovery that is shaking the foundations of our understanding of space. This revelation is so significant that NASA had to alert the world. Voyager One's instruments have been gathering critical data on the interstellar medium, plasma waves, cosmic rays, and magnetic fields, pushing the boundaries of human knowledge. Now, as it continues to send back usable information from the edge of our understanding, we stand on the cusp of new discoveries. What astonishing secrets has Voyager One uncovered? How will these findings revolutionize space exploration? Stay tuned as we delve into the latest enigmas from the final frontier and unravel the mysteries of the cosmos. You might have heard about the Cold War, but did you know it was fought on multiple fronts? These include the political, economic, financial, military, diplomatic, and scientific domains. The top scientific race was the development of the atomic bomb, and of course, the space race between the two superpowers. The US and Soviet Union had a tight contest in space exploration. It was a race to see who could do the most fantastic stuff in space, building rockets, launching satellites and telescopes, landing on the moon, sending things into space, and even bringing back space samples to Earth. To beat the Soviets, the United States put billions of dollars into the race. It was like spending all your piggy bank money, then your parents' money, and maybe even some of your grandpa's money, all on a single mission to beat your enemy for the trophy. But here is a fact that will surprise you. Despite the tedious scientific efforts and billions spent, 2 advanced spaceships America built might not have launched. Here's why. The planets Jupiter, Saturn, Uranus, and Neptune lined up specially. This alignment acted like a giant slingshot in space. The spaceships were meant to use the pull of each planet to speed up, just like it was getting yanked by an invisible rope. But there was a catch. This perfect alignment only happened once every 176 years. To take advantage of this slingshot effect, a spacecraft must launch by the mid-1970s, when the planets were lined up just right. Luckily, NASA built not 1, but 2 spaceships to make the most of this rare opportunity. Had it been that opportunity was lost, it would have taken almost 200 years to have another shot. In one of the most remarkable moments in the history of space exploration, NASA scientists launched 2 nearly identical spacecraft, Voyager One and Voyager Two, just 15 days apart in the summer of 1977. But here is the biggest shocker. These fantastic machines have been flying through space for almost 45 years, sending information back to Earth from farther away than any other spacecraft. They've even ventured beyond the edge of our solar system and into interstellar space, becoming the first human-made objects to do so. NASA making a historic announcement today that the Voyager probe has entered interstellar space, that place between the stars. Surprise, surprise. These Voyagers are champs. They've lasted way longer than their original mission plan of just 4 years, and they're likely to hold this record for a while since they're still going strong. Do you know what is more surprising? They were only meant to study Jupiter and Saturn for a few years, but they gave us mind-blowing discoveries about those planets, including their moons. Marvels of the Voyagers. The Voyagers spent little time after launch before streaming data back to Earth. The first discovery they sent back to us was super cold, distant satellites that weren't dead rocks like our moon. They even found active volcanoes and cracked ice fields. Voyager 2 was a pioneer, the first to visit Uranus in 1986, and Neptune just 3 years later. On January 24, 1986, NASA's Voyager 2 spacecraft flew by Uranus. This was the first time that any spacecraft had ever visited Uranus. No other spacecraft has ever followed its path. Not even the Soviets or Russians have achieved this feat. The Voyagers are over 12 billion miles from Earth today. And guess what? The Voyagers keep finding new things that challenge our understanding of space science. But unfortunately, their journey is nearing its end. NASA has been turning off heaters and other non-essential parts for the past few years to save energy and keep them going as long as possible. They hope to stretch the battery life until around 2030. That's not all. The termination will be a mix of happy and sad news for the scientists who've been with Voyager since day one. The project has gone beyond their wildest dreams, but it's nearing its end. Here's the timeline. Voyager One reached Jupiter 546 days after launch in March 1979. Voyager 2 took a different path and arrived in July 1979. In 1979, NASA's Voyager 2 spacecraft made its closest approach to Jupiter. The spacecraft was one of two Voyager probes NASA launched in 1977 to study the outer planets. Both had special cameras with red, green, and blue filters to take amazing color pictures in space. To get these clear shots, they spin incredibly slow, way slower than the second hand on a clock. This keeps them steady as they travel through space. Another surprise is just around the corner. Even before reaching Jupiter, the Voyagers started sending back incredible images, much to the excitement of scientists on Earth. The first shocker was LO's colorful appearance. Before the mission, everyone thought all moons would be dull and cratered like ours. But LO was bursting with color. The Voyagers also found a crazy variety of moons around Jupiter and Saturn, way more than anyone expected. It all started with some strange signals picked up by a special instrument on the spacecraft when they were still millions of miles from Jupiter. These signals were from Io's active volcanoes, which the Voyagers later captured in stunning pictures. Amazing discoveries of the Voyagers. The most amazing discovery then was LO. It is a world just a bit bigger than our moon, but turned out to be the most volcanic place in our solar system. Think about mountains spewing out material that paints LO with colorful streaks. That's what the Voyagers discovered. On March 8, 1979, NASA's Voyager One spacecraft discovered active volcanoes on Jupiter's moon Io. These eruptions also explain the weird signals the spacecraft picked up millions of miles away. Wait for a lifetime surprise. A giant volcano known as Pele blows smoke plumes 30 times taller than Mount Everest, and its ash field could cover almost all of France. The Voyagers captured 33,000 images of Jupiter and its moons, and each picture revealed something new. Jupiter even has rings. Europa, another moon, has a cracked icy surface that scientists now believe is over 60 miles thick. It was pretty easy for the Voyagers to leave Jupiter. Can you guess why? Remember the giant slingshot we mentioned earlier? Thanks to gravity, the Voyagers got a boost of 35,700 miles per hour, which they needed to escape the pull of the sun and travel farther in space. When they got near Saturn, they went in different ways. Voyager 1 flew by Titan, a moon blasting in an orange haze, before heading north and out of the plane of the planets. It even took hundreds of hits from dust particles while zooming through the rings of Saturn. But trust NASA, the spacecraft took every beat like a real ranger. Meanwhile, Voyager 2 journeyed on alone. In 1986, it made a significant discovery near Uranus, 10 new moons. Voyager 2 flew within 50,600 miles of Uranus and took the first and only close-up photos of the planet. During the encounter, Voyager 2 examined the rings around Uranus and discovered 10 of its 27 known moons. This added a bunch more to the already impressive ring system of the planet, and with each discovery, our knowledge of space science improves. Voyager 2 kept exploring, and 3 years later, it reached Neptune. By August of 1989, Voyager 2 was speeding more than 40,000 miles per hour toward its rendezvous with Neptune, where it found the fastest winds ever recorded on a planet in our solar system, whipping around at a mind-blowing 1,000 miles per hour. That's not all. Neptune has a beautiful blue atmosphere, but it's not a place for your next picnic. Voyager 2 flew just 3,000 miles above it, and even at that distance it measured a surface temperature of a bone-chilling 391 degrees Fahrenheit. The coldest moon on Neptune, called Triton, turned out to be one of the coldest places in our solar system, with a surface temperature more frigid than ever recorded. It's so cold, it even has ice volcanoes that erupt with nitrogen gas instead of lava. Would you love to take an excursion there? Let's have your views in the comments section. Before we go on, it is essential to mention Carl Sagan here. He was a famous astronomer involved with the Voyagers missions. He knew the importance of capturing photos of Neptune and its moons because once Voyager 2 finished exploring them, NASA planned to turn off the cameras. These pictures would be the last ones ever taken by the spacecraft. Without Sagan's foresight, we wouldn't have these incredible images of Neptune and its icy wonders. Even though the mission was extended when NASA hoped the Voyagers would reach interstellar space, Carl Sagan wasn't ready to take the risk. He convinced NASA to let Voyager 1 take one last set of pictures before turning off the cameras. On Valentine's Day in 1990, Voyager 1 turned back and snapped 60 final images, including the most famous one known as Pale Blue Dot. This was the Pale Blue Dot. This was our willingness to see the Earth as a one-pixel object in a far greater cosmos. This picture shows Earth from a record-breaking distance of 3.8 billion miles. It's a speck, barely visible because of the faint sunlight reflecting off the camera. Both Voyagers are now incredibly far away. For you to have a good idea, radio signals sent at the speed of light take 22 hours to reach Voyager 1 and 18 hours to reach Voyager 2. That's how far they've ventured into space. But how do we still communicate with these devices venturing so far from our planet today? Stay tuned for the most exciting moment of this exploration: secrets of space messaging. Even though Voyager 1 travels millions of miles each day, it takes messages from Earth a whopping 22 hours to reach it. This is because information travels at the speed of light, which is fast, but has yet to be instantaneous. Keeping in touch with Voyager is like trying to talk to someone on a walkie-talkie. As Voyager gets farther away, the signals get weaker. It's like whispering across a giant, noisy room. Everything on Earth, from radios to cell phones, creates a kind of space chatter that makes it even harder to hear Voyager's faint messages. Despite the challenges, these weak signals have revealed some surprising things about interstellar space, the region beyond our solar system. This differs from the solar system's edge, where the sun's influence stops. Scientists should have expected what Voyager defined in this far-off territory. Sit tight for the big revelation. Imagine the sun as a giant bubble blower. The bubble it creates is called the heliosphere, and it's made of charged particles and magnetic fields streaming out from the sun at superfast speeds. The heliosphere is like a giant protective bubble created by charged plasma particles blowing out from the sun. This stream of particles is called the solar wind, and it surrounds the sun and most of the planets of the solar system. This bubble protects our solar system from hazardous stuff floating around in interstellar space, which is the vast region beyond our solar system. The edge of the heliosphere isn't a sharp line. It's like a fuzzy border where the sun's influence weakens and interstellar space begins. This zone even has a name: the termination shock. It's like a wave created when the sun's wind bumps into the interstellar breeze. While it will take Voyager hundreds of years to reach the heliosphere's edge, it's already crossed the termination shock and entered interstellar space. That's a big deal because it's a new part of the universe for us to explore. The potential of these two siblings racing in space will only be limited by battery capacity. Consider the heliopause as the border between our solar system and interstellar space. Before Voyager, scientists needed to figure out exactly where it was. Some guesses placed it as close as Jupiter, while others thought it might be much farther out. In 1993, a scientist named Gurney estimated the heliopause to be around 25 times farther than Earth is from the Sun. That's a considerable distance. His calculations seemed pretty good, and around 20 years later, Voyager 1 finally crossed into interstellar space. Here's the surprising part. When Voyager 1 reached the heliopause, it detected a significant increase in the number of particles in space, just like scientists expected. But there was one weird thing missing. The direction of the magnetic field didn't change. Scientists thought this direction would shift because inside the heliosphere, the magnetic field comes from the sun. But outside, it should be influenced by other stars. This unexpected finding means there's still a lot we still need to learn about heliopause and interstellar space. Voyager's biggest discovery. In November 2018, Voyager 2 followed its twin into interstellar space. On November 5, 2018, Voyager 2 left the protective bubble of the Sun and joined its sister ship, Voyager One, on an interstellar mission 41 years after it launched. Voyager 2 became just the second spacecraft ever to reach interstellar space. Just like Voyager 1, it didn't see a change in the magnetic field direction when it crossed the heliopause, which is the border of our solar system. This was another big surprise for scientists. Theories predicted the heliopause might move closer or farther depending on the Sun's activity cycle, but neither Voyager encountered this. According to experts, Voyager 2 crossed when the solar wind was strongest, which should have pushed the heliopause further out. These unexpected findings mean scientists must rethink their models of how our solar system interacts with interstellar space. Thanks to Voyager's data, we're getting a clearer picture. There are two big lessons. Our Sun leaves a hot, ionized zone filled with charged particles and enters a partially ionized part of the galaxy. This hot zone might be a leftover effect from a giant explosion or supernova of a nearby star long ago. Supernovas are a big, giant, dramatic end to a star's life. For a star to go supernova, we think it has to be at least 8 times more massive than our Sun. The explosion likely heated the area and ripped electrons from atoms, creating our current zone. Here is a more precise picture. The edge of our solar system looks like a seashore. On the beach side, the water is all stirred up with waves crashing and mixing. That's what the magnetic field is like in this area. It is all twisted and jumbled because of the influence of the Sun. Scientists like to picture things as smooth and straightforward, but nature could be better. Thanks to the Voyagers, we now understand this boundary could be more calm and clear-cut. Many small changes are happening in the magnetic field as you get closer to the edge. The excellent news is Voyager is expected to eventually sail past these choppy waters and enter a region with a steadier, pure, interstellar magnetic field. That will be a significant scientific discovery. We can't wait. Powering the Voyagers. Saying goodbye to these fantastic spaceships won't be easy. It's like watching a long adventure come to a close. We'll come back to that soon. Voyager 1 has 4 instruments still working and Voyager 2 has 5. Are you curious about how they get their power? They both use a special power source that turns heat from plutonium decay into electricity. But this power source is getting weaker by about 4 watts each year, like losing a few batteries yearly. Because of this, scientists have to choose which instruments to keep running carefully. It's a tough call. It is like a doctor being forced to shut down vital organs in the body of a patient. NASA only decides what to turn off and keep after delicate consultations. That's not all. Voyager's journey will continue even when they can't send signals anymore. In a mind-blowing disclosure, NASA suggests that Voyager 1 will fly by Proxima Centauri, our closest neighboring star, in about 16,700 years, a planet orbiting the Sun's nearest stellar neighbor, the red dwarf, Proxima Centauri. Voyager 2 will follow suit 3,600 years later. That's long after our Sun burns out and the heliosphere disappears, and these Voyagers will still be out there, silently exploring the galaxy. They may even outlast our tiny blue dot, Earth. That's an incredible legacy. Even though Voyager won't be able to send messages with radio signals anymore, they might still have a final farewell. It won't be a broadcast, but a time capsule attached to the spacecraft. These capsules are not plastic. They are made of copper, plated with gold, and protected by aluminum. NASA nicknamed them Golden Records. They hold sounds and images that tell the story of our world to whoever might find them someday. Voyager carries a golden record, containing a greeting from the people of Earth to the alien life form that may someday find it. On the record is a collection of images and sounds. The recordings on the golden record are 90 minutes long. There's all sorts of stuff on there, like music from Bach and Chuck Berry, pictures of kids in nature, and even everyday sounds like crickets chirping and a mother kissing her child. It's a snapshot of life on Earth for any alien civilization that comes across Voyager in the future. Do you think aliens will capture the Voyagers someday? That's a story for some other day. There is more. Jimmy Carter, the United States President when the Voyagers were launched, also left a message on the Golden Record. It is like a greeting card for aliens. The message says, "We're sending this message out into space, hoping someday to meet other civilizations in the galaxy. We hope we've figured out our problems on Earth by then, and we can join a big space community together. This record shows our hope, our determination, and our friendly feelings for whoever might find it in this giant and amazing universe." End of the Voyagers. Remember what we said at the beginning? The Voyagers are tireless travelers, and everyone keeps asking, where will these restless hustlers go next? According to NASA, Voyager One is headed towards the constellation Ophiuchus, while Voyager 2 is on a path to Cetus. Some scientists predict their journeys might end around 2030 when their power runs out. But even if they can't send signals, they'll likely keep traveling for millions of years, way longer than humanity will be around. This is because they will likely continue to float with the help of gravitational pulls. Probably, extraterrestrial bearings from another planet will get hold of the two Voyagers. If they do, they will likely find the Golden Record, and we hope they understand the language and message of a long-lost civilization called humans. It would be an incredible discovery, filled with mysteries about our world. Who knows what they might do in return? There's a question lingering on everyone's mind. What will replace the Voyagers? Reports suggest that NASA wants a new mission that will travel even farther. This next interstellar mission will be designed to last much longer than Voyager. Scientists at the Johns Hopkins University of Applied Physics Laboratory, APL, believe they can build a probe that could run for over 100 years. That's way longer than a human lifetime. Imagine the incredible discoveries it could make. NASA's new mission is called the Interstellar Probe, and there are rumors it could launch sometime in the 2030s. This probe will be the superpowered sibling of the Voyagers. It will travel faster and farther than anything we've ever built. Experts believe it will zip past planets and explore territories the Voyagers never touched. While running within our solar system, the Interstellar Probe might even visit some icy dwarf planets on the outskirts of Earth. Scientists believe that some of these planets might have once been giant oceans millions of years ago, and maybe we will find out soon. That's not all. The fundamental goal of the new Voyager will go beyond our solar system. The Interstellar Probe will venture into the unknown areas of interstellar space, a place we've never been before. It will even be able to take a picture of our solar system from the outside, giving us a whole new perspective on our celestial neighborhood. This will be a giant leap forward in our understanding of the universe. Remember, these are speculations about the capabilities we think this machine would have, but we are still determining all it will give us. Here is another iterating fact. The Interstellar Probe will be a real speedster. Early plans suggest it'll travel at least twice as fast as Voyager One, racing through space at breakneck speeds. This incredible speed means the probe could travel a mind-blowing 375 astronomical units, or 34 billion miles, in its first 50 years. To give you an idea of how far that is, 1 astronomical unit is the distance between Earth and the Sun. If the Interstellar Probe keeps going for another 50 years, it could reach 800 astronomical units, a whopping 74 billion miles. This would be an incredible feat of engineering and exploration. Interstellar missions present a new set of challenges compared to past space endeavors, but surely we can do it. While the Interstellar Probe will be fast, remember that credibly vast. Even though the probe might travel billions of miles in its lifetime, that's just a tiny dent compared to the distances between stars. Proxima Centauri, our closest neighbor star, is 25 trillion miles away. Reaching another star system with our current technology would take thousands of years. While this might seem disappointing, it's important to remember that every journey begins with a single step. Do you think man will ever be able to conquer space? Share your opinions in the comment section and remember to click the like and subscribe button.